This problem number 9 is meant to simulate what we did in the lab with the magnesium oxide. When you look at this, there's givens. This is manganese, and this is how many grams of oxygen there are. For the first problem, since we're working with manganese, we're going to just use that 4.6105, and we're going to calculate the unknown that we're trying to get to is moles. So when we set up this equation, what we're going to do is first do our given, which is 4.6105 grams of manganese. And then for the next part, we're trying to convert from grams to moles. So I need something that will convert me the molar mass, grams of manganese, to moles. In this case, I don't have the molar mass given to me. I actually have to look it up. So I've got to go on the periodic table, and I find manganese on the periodic table, and it's 54.938. And so that's going to be the mass of 1 mole of manganese. So 54.938. And that's equal to 1 mole. So when I do my math, I'm going to divide to get my answer. And I get an answer of 0.0839 moles of manganese. The next part of this equation, or next B I should say, is trying to figure out the moles of oxygen. So when I set this problem up, I start with my given again. My given, instead of being the manganese, I'm going to use the given for oxygen, and that's the 0.08951 grams. So that's how many grams of oxygen I have. So I put that on top, and that's equal to, well, I'm trying to convert this to moles. So I've got to find an equation or a ratio, one of the fractions, that will get me from grams to moles. The fraction that I'm going to use is the molecular weight. And 1 mole of oxygen, to figure out its weight, I look on the periodic table. And when I look on the periodic table, I see that oxygen has a weight of 15.999. So that is the mass of 1 mole of oxygen. And I'm going to divide the given by 15.99 to get me my moles of oxygen. That's 0.0559 moles of oxygen. Now, the third part of this question, based on the moles calculated, what is the empirical formula? When you think of empirical formula, what I want you to think of is mole ratio. The empirical formula is showing us what's the ratio between the two elements. In this case, we have manganese and we have oxygen. Now, this is a generic way of writing the empirical formula. What that means is that you could have MnO, MnO2, Mn2O, any whole number ratio, Mn2O3 for example, Mn3O2. But it keeps going. Any whole number ratio is possible on this. What you need to figure out based on this data is what is the ratio. So ratio, what I hope you think of, is division. Moles of, in this case, we have 2 numbers that we got, which is moles of manganese and moles of oxygen. We're going to figure out the ratio by dividing them. What is the ratio? How many times bigger is 0.0839 than 0.0559? When you plug that into the calculator, you get 1.500 and then some numbers after that. Well, this is 1.5. Think of this as 1.5 over 1. Now, I want to make this a ratio, and remember that the 1.5 represented the manganese and the 1 represents the oxygen. So I want to make this number or ratio a whole number. If I multiply both the top and bottom by a certain number, it will make them a whole number. So the trick is knowing that the 0.5, if I multiply it by 2, that I'll get a whole number. Well, I have to multiply the top and bottom by the same thing to keep that ratio the same. And that ends up getting me 3 over 2. What that means is there's 3 manganese for every 2 oxygens. That tells me that the right empirical, the right empirical formula is 3 manganese to every 2 oxygen. So the answer is Mn3O2.